ENPM636, formerly ENPM808G, Additive Manufacturing for Aerospace, Energy, and Water Applications, is taught by Drs. Sarmiento and Michael Ohadi. This course provides students with an in-depth understanding of additive manufacturing technologies and their applicability and limitations. It is important for future engineers and researchers in developing new engineering systems and identifying emerging opportunities in developing new products and processes. Real-life projects and the advancements that are realized through utilization of additive manufacturing techniques will be presented in this course. The following is an excerpt from a class session taught by Dr. Sarmiento to provide a sense of what you will expect from this course.
So, what about the course description and goals? First, we want to get like in deep understanding of additive manufacturing technologies, okay? At least like the main idea, okay? So, it's not possible to do additive manufacturing in practice for all the techniques, okay? Because it's time consuming. Okay? So, also the main goal, or one of the main goals of this course, will be understanding of various additive manufacturing techniques, applicability and limitations, okay? As we know, like additive manufacturing techniques are growing around the world, are good, but as probably you know, you have some limitations in the application of the technique, okay? Mostly related to the construction, okay? So, but hopefully we'll see like a lower or less restrictions in the future, okay? We know like the development of additive manufacturing techniques as well as other related techniques are growing, okay? So, and then identifying emerging opportunities in developing products for mass customization. Our focus will be mainly in additive manufacturing applied to thermal management or energy, okay? So, principally, we'll be talking about heat exchangers, heat sinks, and energy-related devices, okay? One thing is very interesting about like the emerging opportunities. We'll be talking about like the topological optimization. It's not a new topic in terms of structural optimization, okay? But it's a very, very related new technology for thermal applications, okay? I will say like it's like probably 5 years now, okay? Probably a little more, but it's a new technique, okay? We'll be, we'll see like a little bit about topological optimization, okay? Familiarity with like enabling features of design optimization for additive manufacturing is good, okay? We'll need to know like about material properties, okay? Not only related to additive manufacturing, but in general, okay? So advanced in computational techniques for AM fabricated material characterization is important, okay? So emerging relation between additive manufacturing and machine learning, okay? It's not like a required, you need to know this, okay? But it's like we'll see a little bit about to get like an understanding of it, okay? So some case studies on application in target industrial sectors. As we know, like additive manufacturing as well, other manufacturing things are applied in a very broad applications in industry, which includes aerospace, defense, energy, water harvest application. And then we will review in some emerging techniques such as process material and 3D scanning, okay? A little bit to get like a very, very broad idea of what we are talking about, okay?